So we're getting ready to study the law of conservation of matter, otherwise known as the law of conservation of mass. We've talked about changes in matter, for example, the evaporation of water, or a puddle of water, or the rusting formed on a metal fence. This one's going to be physical, so evaporation of water, physical, and rusting would be an example of chemical. However, in both of these examples, no matter is created or destroyed by any changes. In other words, the total amount of matter remains constant. So how did scientists come up with this law? Well, they measured the mass of the reactants, or the stuff that goes into the reaction. And then they measured the reaction after it took place. So they measured the mass of the products. That's the stuff that's left over. So here's the law of conservation of matter. It says, during a chemical reaction, matter cannot be created or destroyed. So in other words, even though matter can change form from one form to another, the same number of atoms exist before and after the change. So the mass of the reactants equals the mass of the products. Here's an example of the law of conservation of mass. We have a test tube containing lead nitrate, and it's going to be placed in a flask that contains potassium iodide. So what are these guys going to be? These guys are going to be the reactants. That's the stuff we're putting into the reaction. And right now they're not going to mix. We're going to put a stopper in the top of the flask, and we're going to create a closed system. And what a closed system is, it's just going to be an environment where no matter can come in or leave. Okay? And we're going to put this on a scale, and we're going to get the mass of it. And so right now it's going to weigh 238 grams. We're going to go ahead and flip that over and mix it up. And now we're going to make lead iodide and potassium nitrate. Okay, so the matter has changed form, so we've made new things, but the total mass has not changed at all. So we weigh it again, and it's 238 grams. Okay, we're going to do another example here. So we have iron, and you know what iron looks like. It is hard gray colored metal. And we have some rust. Rust is going to be some flaky orange red solid. So when iron reacts with oxygen in the air, they're going to form rust. And another name for rust is iron oxide. That's the technical name. Okay, so this is the actual chemical equation for it. So iron plus oxygen makes iron oxide. So here we have a representation of this as an atom format, okay? So here are our reactants, the iron and the oxygen, and here are our products, iron oxide. So notice that the oxygen are made of 2 atoms each. Remember, those are diatomic. Now let's look at the numbers that we have, okay? So how many iron atoms do we have? So if you count them up, we have 4. And how many oxygen atoms do we have? If you count them up, we have 2, 4, 6, right? So then let's look at the products. So how many irons do we have in our products? We would have 4 total, right? 2 plus 2. And then how about how many oxygens? So we would have 3 plus 3, right? So we would have 6. There's a typo. We have 6 irons. I don't know where that came from. Okay, so all chemical reactions follow the law of conservation of matter, like we just witnessed there. When iron oxide, the mass stays the same. The total number of iron atoms and oxygen atoms in the reactants is the same as the products. The atoms were just rearranged. So no new atoms were created and none were destroyed. Okay, so we're going to do one more thing before we're done, and we're going to determine the mass of reactants and products. So one thing to remember here is that the mass of the reactants is always equals mass of the products. So here's our example. So we have 10 plus hydrogen fluoride, and we're going to make 10 fluoride plus hydrogen. So here's the mass of 10. We have 118.7 grams. And here's the mass of our hydrogen fluoride, 40.02 grams. So then, my question to you is, what is the total mass of the reactants? Well, to figure that out, we would just add them together, right? So 118.7 plus 40.02. So that would be 158.72 grams. Just add them together. So another question to you is, so what would the mass of the products be? So if the mass of the reactants is equal to the mass of the products, they would be the same thing, right? So 158.72 grams. Okay, so one more thing with this. So we have the same equation here. We have 10 plus hydrogen fluoride, and that makes 10 fluoride plus hydrogen. So the total mass of the reactants we just said was 158.72. Okay, so now I know that I make 156.71 grams of tin fluoride. Here's the question. How much hydrogen did we make? Can you figure out how to figure that question out? Right, well you just subtract, right? So you do 158.72 minus 156.71. Okay, and so that would just be 2.01 grams. So these problems are pretty easy, just kind of common sense stuff. So right now I want you to make sure you write down any questions that you have and bring them to class tomorrow, and we can answer those while we do the lab.